17 tips from a senior React developer. We've actually looked at some tips from this guy before and they were pretty good. So I'm going to go through these and give some of my own opinions on them as well. And I'll tell you where I agree as well as where I disagree. So this guy's been writing React code as an engineer at Palantir for over 5 years. Okay, so number one, learn JavaScript before React. I've said this a million times on this channel and I 100% agree with this. He says it's a common mistake for junior developers trying to learn React without a solid understanding of JavaScript. It's a recipe for confusion because you won't know what is React specific and what is just JavaScript, and debugging becomes a nightmare. And I would actually go even further than this and say it's actually not just a common mistake of junior developers, although it is a common mistake of junior developers. It's a common mistake I've even seen seniors make where they end up working in some React code base when they haven't done much front-end work before, and they don't take the time to actually learn JavaScript. And as a result, they end up writing really bad React code. I like to think of React, as well as pretty much any library or framework that we use, as being sort of a shortcut, a simplification process to make it easier to write that code, to make it more efficient to write that code, all of these different things. But if you don't know how to do it on your own in vanilla JavaScript, you probably shouldn't be doing it with React or something like that. Does that mean you need to be an absolute expert on JavaScript before learning something like React? No, absolutely not. But just make sure that you have some of the fundamentals down before you learn React, as well as make sure before you even learn JavaScript that you have the fundamentals of HTML down, because ultimately we use JavaScript as a language to manipulate HTML. So if we don't understand HTML, we won't understand what it is that we're even manipulating. And then we use React as a tool to make JavaScript easier. So if we don't understand JavaScript, then we're not going to understand what exactly it is that we're making easier. And all of that is just a recipe for a lot of confusion down the line. So learn HTML first, and then JavaScript, and then React. All right, number two, read the React docs. You don't need money, a coach, or a fancy course to learn React. Here's the official React website, and follow the quick start guide, read the learning chapters. Yeah, 100% I agree with this. The React documentation at one point wasn't all that great, but they actually redid it a few years ago and they've been upkeeping it very well. And it's actually a very, very good resource at this point and obviously completely free. So 100% I would say read the React documentation. If you're somebody who's worked in React for a while, what I would say is just go and read the entire thing. It won't take you that long. There's not actually that much to it. And if you're somebody just learning, then go through it kind of slowly and take it one step at a time, almost like it is a course. And I think you'd be amazed how much information you will find in the React documentation that either is never in any of these courses or actually contradicts a lot of the popular courses, because even people making courses on React oftentimes don't have as deep of a knowledge of React as you would expect them to. And by the way, that doesn't mean that you can't take a course. I think courses can be good, and oftentimes people should take courses, whether it be free courses on YouTube or paid courses, but just also make sure you read the official documentation. Okay, start building projects early. Watching tutorials won't make you a React developer. Spending $100, $200, or even $700 on courses won't either. What will? Building projects. It's the best way to learn by making mistakes, discover gaps in your knowledge, and pick up new patterns and tips. And then he gives some resources for finding different ideas for projects. I mostly agree with this, although I do think you need to do a bit of both. If you just build projects, then you won't learn what you don't know you need to know, essentially. But if you just do tutorials, then you won't understand what it is you didn't understand about those tutorials if all you're doing is just copying what somebody else is doing. So try to find a happy medium of doing some tutorials and then doing some of your own projects, going back and doing more tutorials, then doing more projects, and so on and so forth. And one thing I like to do for finding projects is just sort of recognize it doesn't matter what exactly it is you're making. It's not all that important. All that really matters is that you're actually building things, because it's not like you're building some massive startup or something like that. You're just building projects for the purpose of learning, and to do that, it really doesn't matter what it is. So what I like to do is just go to some tutorial, follow the tutorial, and then at the end, when you have that project finished from the tutorial, try to add something substantial to that project. So make sure that you understand the project by doing something in addition to it that was not given from that tutorial. All right, number 4, use trusted libraries. Not all packages are safe. For example, in 2021, a popular NPM package was hacked, spreading malware. To minimize risks, use libraries from trusted authors and check for good download volumes and regular updates. Yeah, I think I mostly agree with this, although I think it just depends on what exactly the context is. If the context is learning, I would say use as few libraries as possible, because ultimately they're just shortcuts. And when you take these shortcuts, you are actually minimizing your ability to learn how to do that thing yourself. And then if you're working on projects that you are planning to actually release, I would say the most important thing is just to build the thing, right? Get it working, get that MVP out there. And for that, I would say use whatever libraries you need to use. Of course, don't use something that has like 2 stars on GitHub. That's probably not going to be a good idea. And also don't use things that haven't seen an update in like 5 years. Also not a good idea. But you can sort of use things that you know in the long term you might want to replace, just because you want to get that project out there. Because there's nothing worse than spending a ton of time implementing your own thing when that already exists in open source, just to find out that after the users try it, that they don't even like that feature and that you didn't need to do it at all, versus you could have just used the open source thing to get that user feedback going very quickly. And then of course, if you're working on bigger production code bases, you want to be much more careful about what libraries and what dependencies you actually introduce into those projects. All right, number 5, solve problems with vanilla JS when possible. Previously, you needed libraries like Lodash for tasks like cloning, iteration, etc., but modern JavaScript has improved a lot. Now you can achieve a lot with native methods, so don't add a library if you don't have to. Why? Every library you add increases the app's dependencies, making it more vulnerable to security issues. That's true. Potentially adds to your bundle size, slowing down load times. This can also be true, although with things like tree shaking, it's not as important sometimes. Like, it's not always going to add as much as it might seem, but at times it can add a lot. You do want to be careful about increasing bundle size too much. And then it increases your app's build/compilation time. This can be true too, although with most React applications, this isn't going to be a huge issue. Like, you're not going to be running the build process all that often, and it's not going to take all that much time. Although in some instances, this can be a bigger issue. And then creates maintenance overhead to keep dependencies updated. Yeah, this can be true as well. So before reaching for a library, check if vanilla.js can do the job. It often can. Yeah, a lot of things that used to be in tools like Lodash are just very easy to do with modern JavaScript. So there's just no reason to actually include these whole libraries just to use a couple functions when you can just implement those functions yourself. And also this means that you can get a simplified version of those functions, which oftentimes is going to be more efficient because you don't have a bunch of code for, say, different options and things that might come with something like Lodash when you don't actually need all of those options in your own code base. All right, number 6, optimize bundle size and lazy load as much as possible. It starts slow. You add one package here, then another there, then another. Before you know it, users complain the app takes too long to load. Developers complain the build process is painfully slow. Why does this happen? Because packages and heavy components were added without considering their impact on bundle size. How to fix it? Lazy load as much as possible. Yeah, so this is a good one to do a lot of the time. So lazy loading, if you don't know, is essentially the idea of, well, being lazy about loading some things. So don't load in things that the user doesn't need immediately until after you've done all of the processes necessary for just making the website or app or whatever it is actually usable. So for example, if you have like this advertisement over here for GitLab, this has an image, and that image can take some time to load in. So you can lazy load that because the user doesn't need to see this advertisement immediately. So just get the content to them. And then once they can see the content and they can interact with the page, then go and fetch this image for this GitLab advertisement. And then set up checks to track bundle size increases. Pull request actions work well for this. Yeah, I think that's a good idea. And use bundle phobia to check package size before adding it to your project. Yeah, I've actually talked about bundle phobia in a video before, but I'll open this up. So for example, if you want to add Lodash, you can search for that, and it's going to show you essentially what this is adding to your bundle size, as well as the download time. So how long does it take to download Lodash on a slow 3G connection and on a 4G connection? Now, again, I don't think this is a perfect metric because you are going to be able to use things like tree shaking to not actually include all of this package. But it is still good to be aware that some of these packages are much larger than they might seem, and when you add enough of them, you're actually adding a lot that needs to be downloaded. Co-locate related logic. Grouping files by type, e.g. components, utilities, internationalization, might seem like a good idea, but it's not. Why? It's harder to follow a component's logic when files are scattered. You risk cleaning a component but forgetting related files. Instead, keep all your components' logic and assets together in one folder. Yeah, I think I mostly agree with this, although I think it depends on the type of project you're doing. For a small project, I think just having like a components folder and things like that works pretty well. But for a larger project, it's just not going to scale very well, and you should organize in a different way. The way I like to do it is to have that high level like components and utilities folder, but these are for global things. So for example, if you have some global design system, so for example, maybe you have a button component that you use across the entire code base, put that at the top level in a components folder. And same thing with utilities. If you have some utility functions that get used a lot, put them in the top level. And then you want to have a bunch of different folders for either different features, different pages, or it might depend exactly on your repository and how you want to organize it, but essentially just put related logic together. And actually a tangential benefit of this is actually going to be with AI. So we have a lot of AI tools now that are trying to work in our repositories, but they can't possibly look at every single file in your repository to try to figure out how to do something. So I do expect, although I can't say this for sure, but I would expect that if you are using some of these AI tools, if the files are nearby each other, they're more likely to be the files that the AI is actually looking at, and it's more likely to find the correct solutions. So I do think that is potentially another benefit, although it's not something I've tested enough to actually know if that's true, but that would be my sort of gut feeling, is that you would get that as a benefit as well. Okay, number 8, keep components simple. Avoid God components, those that try to do everything. They're problematic because they're harder to read and understand. They often lead to version control conflicts. Modifying them can unintentionally impact the entire app. So what to do instead? Think about how you'd structure your code if you were working with a teammate. Interesting. I actually really like this as sort of a heuristic for when to break up code. So this idea of if you were working with, say, 2-3 people and you were to divide this up, how would you divide up those tasks? Who would work on what? And those individual tasks would almost make sense most likely as individual components. And if you look at a component and say, no, there's no way that I could be working on this with somebody else, there's no way to divide this up, then it's probably divided up as much as it can be, and it's probably at the correct size. I'm not sure this is a perfect heuristic and it's always going to work, but I do think I like it from sort of a high level. Then also you can just think about, try to keep things simple and keep components to doing a single thing. And that's sort of what it says here as well. Keep your components focused on one task to minimize conflicts. This approach keeps your code clean and helps your team work more efficiently. And I would agree with that. All right, number 9, solve diverse problems. The more problems you solve with React, the better you get. And I think this is true with anything, not just React. Every challenge you tackle teaches you something valuable. You uncover new patterns and anti-patterns. You add more tools to your developer toolbox, and you gain confidence in your skills. But here's the key. Don't just practice, vary your practice. Yeah, I would agree with this. And I think it kind of comes down to this idea of people who spend all their time in tutorial projects, because there's lots of tutorials and you can do lots of different tutorials and they feel like different things. But the thing is, if I make a tutorial project and say Tech with Tim makes a tutorial project and maybe I don't know, some other YouTuber makes a tutorial project, we're all probably trying to teach you similar things. So even though the project at its sort of surface level is different, the key things we're teaching you and sort of the roadblocks we want you to run into are all going to be very similar, and you're not going to get a very varied version of practicing. And this can be hard to figure out exactly, but essentially just the more variance you can find in the work you are doing, the more likely you are to be solving these diverse problems and learning even more. All right, number 10, learn good programming patterns. As a React dev, you should also focus on foundational programming skills, data structures and algorithms, sets, maps, recursion, principles like those in the pragmatic programmer. Yeah, 100% I agree with this. I think a lot of people think, oh, front-end developers, they don't need to know things like data structures and algorithms. And sure, you might use them a little bit less than you would on the back end, although I think in both you don't actually use them all that often. However, they are still very important. To be fair, I can't say I've ever actually used recursion in a production codebase, but things like sets, maps, stacks, and queues are things that I have used a lot. Additionally, if you're interested in getting a job as a front-end developer, it's very likely that you still get some of these standard coding interviews that we see for software engineers, which are focused on data structures and algorithms. So even if you think you're not going to be using this on the job at all, which I don't think is true, but even if you think that's the case, you're probably still going to need it to actually get that job. It could depend on where exactly you're applying, but at least if you're applying to the big tech companies, you are going to need these things to be able to get that job. And if you're trying to prepare for your coding interviews, my recommendation is generally to give AlgoExpert a try. So I actually used it as a customer way back in the day, and more recently I joined as an instructor, both on AlgoExpert itself, so some of the algorithm-style coding interview questions I am the instructor on, as well as I'm the instructor for all of Front-End Expert, so the front-end interview prep area of the platform. And there's a good amount of free content on the website, so my recommendation is always to give some of that free content a try to figure out if it's right for you or not. All right, so number 11, read a ton of React code. Building projects isn't the only way to learn. Reading code is just as valuable. I would actually almost go so far as to say at times it's more valuable. So it helps you pick up new tips and tricks, compare approaches to solving problems. So check out open source projects on GitHub. I think this can be helpful, although oftentimes there's so much going on in open source projects that it's sort of hard to understand any of it if you don't spend a ton of time really deep diving into that open source project. So I don't know if this is as practical, but this one, if you are working full time, check out your teammates' code at work. This is a huge, huge thing for me. So this can be in code review, just pay a lot of attention to code review and look at all of the code people are writing and see what you can learn from it. But also just go look at some code people wrote and try to understand it. And if you don't understand it, the people who wrote it are likely sitting right next to you, so you can try to find some time to ask them some questions. And I found that on pretty much every team I've ever worked on, there were like one or two just absolute React wizards who seem to know absolutely everything and have code written in ways that nobody else was writing code. It was hard to describe. They just had what felt like almost perfect React code, and those people were amazing to learn from, and I learned way more from them than I ever did from any courses or tutorials or anything like that. So if you can find some of those people, then do try to use them as a resource to learn from. All right, number 12, use TypeScript as soon as possible. There's a before and after TypeScript. Before, you spend extra time double checking that you've passed the correct props. Debugging can take hours. And then after, you focus on structuring your components and defining types. You catch silly mistakes before they reach production. TypeScript isn't just a tool, it's a game changer for your React workflow. All right, so I think I disagree with this a little bit. So I do think TypeScript is good and you should use TypeScript. That said, I think similar to how you shouldn't use React before you've learned JavaScript, I would say you shouldn't use TypeScript before you've learned React without it. The reason being that I think it's important to understand what is React and what is JavaScript and what is TypeScript. But it will become super useful for certain things. So for example, I think one of the most useful areas in React for TypeScript is making sure that our props always have some type definition so that we know exactly what to expect. That said, I also think you can sort of go overboard with TypeScript and it can become sort of just a distraction. It's sort of almost to me similar to testing. There was a point in time where it was a big thing to get to 100% testing coverage. So the idea being that all of your code is touched by a test. But what most people found over time is that this was oftentimes a waste of time because we were just writing tests that didn't need to exist, testing things that weren't all that important, writing these tests that were trivial in nature and testing things that just weren't going to break. And having those tests aren't necessarily a bad thing, but the result of spending so much time on those tests is that it takes more time to actually build features, and that time just could have been used in a more useful way. And I've certainly seen in code bases where TypeScript has prevented bugs and where it has made things easier to do. However, I've also worked in code bases where TypeScript is overused, and it's sort of this idea of we must type everything in sort of a similar vein to, oh, we must have tests for absolutely everything. And by doing that, oftentimes you actually just make the code messier and harder to actually write. So I would say make sure that you aren't going overboard with TypeScript, but generally speaking, I do agree, use TypeScript, but I don't know about as soon as possible. I would say use TypeScript as soon as you have a good fundamental understanding of JavaScript and React first. All right, number 13, avoid early abstractions. I used to be guilty of this a lot whenever I designed a simple component. I'd try to make it reusable and future-proof. The problem, I often created the wrong abstraction because there were no immediate needs. This led to two outcomes. I'd end up refactoring the code later, or worse, I'd have to live with this awkward abstraction making development harder. So what to do instead? Write a component that solves a problem, and then extend it only if there's a clear need for reuse, and do so gradually. Yeah, I would say this is something I found too, that early on I was sort of taught that we should make components reusable. That's sort of the entire purpose of a component, right? But oftentimes a lot of components don't need to be reused, or we don't know how they're going to be reused. So a lot of times the easiest thing is to just make them not reusable in the beginning, and then if you need to make them reusable down the line, then you can make those changes. But in a way, this is similar to like premature optimization, where we don't need to actually do those optimizations until we actually know that we need them. And oftentimes this idea of making things reusable, especially if it's not actually going to be reused, is just going to make things messier and harder to understand, harder to maintain, and all of these different things. Okay, number 14, use React's built-in state management first. You don't need Redux or Jote, is that how you say that? React's use state, use reducer, and use context go a long way for simple apps. Yeah, 100% agree. And I would actually go further and say it's not just for simple apps. I would say for any application. That's not to say you should never use Redux or any of these other tools, but you can do pretty much anything without them. There was a time when you almost needed Redux, where it was almost like React came with Redux, like they were just coupled together. But because we've added use reducer, we've added use context, and just made state management in general in React a lot easier to do, you don't need tools like Redux. And you can use them if you want, and there's certainly times when they can be useful, but I would not see them as sort of this like default that you need to be using. Number 15, don't mindlessly follow advice online. A few years ago, I read online that memorization was evil, so I stopped using it in my React apps. That was until I crashed an app in production. The advice made sense for the developer who shared it, but backfired for me because I had different use cases. I needed to use effects in my app, and I was working with large-scale components. Main takeaway, don't mindlessly follow the advice you find online. Instead, discuss it with your teammates if you have them, and evaluate whether it applies to your specific context. Note with React 19 optimization, this advice may finally be accurate. Yeah, React 19 does have some crazy stuff around memorization. But I would generally agree with this. And again, I would say we can take this further and say, don't just mindlessly follow advice online, whether it comes from me, another YouTube channel, or it comes from Stack Overflow or whatever, but also don't mindlessly follow the advice of AI. AI is going to give you answers that seem really good a lot of the time, and sometimes they are really good. But oftentimes it's sort of not fully understanding your context, and it's going to give you an answer that is not the best answer for your specific use case. So use these tools and these resources to find answers, but don't just assume that they are always going to be the correct answer. All right, number 16, make time for refactoring. So every now and then, you'll notice that your React components no longer make sense, they've grown complex or too large, and there's room for improvement. When this happens, take 5 to 30 minutes to refactor. Small regular enhancements can make your components easier to manage and prevent headaches. Yeah, I think I agree with this. It's not something I do too often. It's not something I think about too often. And oftentimes I do think it can fall in the area of like, why fix what isn't broken? Like if the component is working and it's not a component that's being actively changed very often or worked on, there's no reason to go refactor something that's already working. But if it's something that you're having to work on a lot, it's getting in the way, things like this, then do go take that time to do that refactor, even if it means you're not taking that time to build a new feature, because ultimately you'll be saving yourself time down the line. All right, number 17, only use frameworks when necessary. Spoiler, you don't need a framework to use React. A simple React Vite and React router setup can go a long way. Use frameworks like Next or Remix only when your app requires their features. Yeah, 100% agree. I think Next, Remix, or something like it is oftentimes something you are going to want for a production code base, but with a lot of projects and things where we're just trying to learn React or building something small, it's just not that important and not something you actually need. And I've seen a lot of people waste a lot of time trying to add these different frameworks and things because it's what they've seen the big companies doing, but it might not be the right choice for you. So just make individualized decisions based on your own projects. But all right, overall, I think this is pretty good advice, but let me know down below what you thought of it all. And if you do want to see the original article he posted with 37 pieces of advice from a senior software engineer, you should watch this video next.